Students, last class we saw that how to find the rank of the matrix using minus method. Okay, this is the method how to find the rank of the matrix using row echelon form. Okay, this is the two important theorems which we going to solve the problems with this method. Okay, this explains that the rank of a matrix in row echelon form is the number of non-zeros in it. Okay, and next one is the rank of a non-zero matrix is equal to the number of non-zero rows in a row echelon form of the matrix. Okay, in a row echelon matrix we simply count the number of non-zero rows and put the rank. Okay, if it is not in a row echelon form, we just change into row echelon form and find the rank of a matrix. Based on this we solve this problem. Find the rank of a matrix, this 3 by 3 matrix, by reducing it to a row echelon form. This matrix is not a row echelon form, so we just reduce it into row echelon form and count the number of non-zero rows. Okay, non-zero rows means the particular rows contains at least one non-zero element. Okay, if in this row all the row elements is 0 means that is called zero rows. Any one element is non-zero means that is called non-zero rows. Okay, first let us assume the given matrix as A. So A equals to 1 2 3 2 1 4 3 0 5. Okay, so first applying the row operations. First we will make these two elements, make it as 0, that is below the first element, that is this is the first element in the matrix. Below 1 2 3 we are going to make this element to be 0, so using the elementary operations. So here 2 is there, so if we subtract 2 from 2 means it becomes 0, so we multiply R1 by 2 and subtract from R2, that I'll write it as R2 equals to R2 minus 2R1. Similarly, R3, 3 is there. To make it 0, we multiplied 1 into 3 and subtract from R3. That is 3 minus 3 0. That is R3 equals to R3 minus 3R1. Okay. So I write it as 2 minus 2. Here 1, 2, 3 multiplied by 2. So we get 2, 4, 6. Okay. So 2 minus 2, 0. 1 multiplied 2 means it becomes 4. So 1 minus 4 minus 3 and 4. Multiply 2 means it becomes 6. So 4 minus 6 minus 2. Similarly, 3 minus 3, 1 into 3, 3, 0 and 0, 2 3s are 6. So 0 minus 6 minus 6, 5 minus 3 into 3, 15. So 5 minus 5, 3 3s are 9, sorry, 5 minus 9. So 5 minus 9 becomes minus 4. So here we make this term as 0. Okay. Next is we are going to make this term as 0. Okay, but first what we do is we just make the below 1 to be 0, and now we have to make the below to this number to become 0. Okay, so this is the R3. So R3 means this is the operation R3 minus 2R2. So write R1 R2 and R3 equals to R3 minus 2R2. So 0 minus 0 0. So minus 6. Minus into minus plus 3 into 6. So 6 minus 6 0. So minus 4. Minus into minus plus 2 into 2 4. So minus 4 plus 4 0. So this is a row echelon form. Okay. So here count the number of non-zero rows. This row contains all the elements 0. So this is a 0 row. This is a non-zero row. And this is also a non-zero row. Since only one element is 0, others are non-zero elements. So here 2 non-zero rows. Okay. So the last equivalent matrix is in a row echelon form. It has 2 non-zeros. Okay, row 1, row 2, it has 2 non-zeros. So rank of the given matrix equals to 2. So this is the one method to find the rank of a matrix. Problem: find the rank of a matrix. A equals to, this is 3 by 4 matrix, that is 3 rows 4 columns. This is a 3 by 4 matrix. Okay, so this is the given matrix. You have to find the rank of the matrix using row echelon form method. Okay, first the order is 3 by 4 matrix. So the rank should be less than or equal to 3. That is, the condition is the rank of a matrix should be less than or equal to minimum of these two. Minimum of these two means 3. 3 and 4. Minimum of 3 and 4 is 3. So the rank should be less than or equal to 3. Okay. So let us transform the matrix A into row echelon form. Here the first element 0. So we simply interchange the row 2 and row 1. Okay. Because the first element should be non-zero. Then only we are able to change into row echelon form. So we simply interchange row 2 to row 1 and row 1 to row 2. This is one of the easiest methods. Okay, I can row 1 to row 2. So I can write row 2 as row 1 and row 2 as row 1. That is row 2 as row 1 and row 1 as row 2, like this. Okay, now 1 below 1 we have to make it as 0. Already 0 is there, so we simply leave it, and we have to make this 3 as 0. So obviously 3 minus 3 0. So multiply row 1 by 3 and subtract from R3. Okay, so 3 minus 3 0, 1 minus 2 3 are 6, so 1 minus 6 minus 5, 1 3 3s are 9, so 1 minus 9 minus 8, 3 2 3s are 6, so 3 minus 6 minus 3. So we'll get this matrix. Now we have to make this element to be 0. Okay, that is below this element. Below, actually this is the first non-zero element in the first row. So we make below this two elements 0, and this is the first non-zero element in the second row. So we have to make this element as 0. So doing the operations, simply multiply row 2 by 5 and add to R3. Okay, so this becomes, so write row 1 as it is, row 2 as it is. So 0 plus 0 0, so minus 5 plus 5 into 1 plus 5, so minus 5 plus 5 0, so minus 8 plus 2 into 5, 2 5s are 10, so minus 8 plus 10 plus 2 and minus 3 plus 5, so plus 2. So this is a row echelon form. After this we are not able to make it a 0, so this is a row echelon form. The number of non-zeros is 3, because this is also non-zero rows, this is also non-zero rows, this is also non-zero rows, because not all the element is 0. Okay, so this is called a non-zero rows. So the number of non-zero row is 3. So the rank of the matrix is 3. So next method is Gauss-Jordan method. This is the method is useful to find the inverse of the particular given matrix. Okay, that is transforming a non-singular matrix A to the form I means identity by applying elementary row operations is called Gauss-Jordan matrix. That is, we have to change the given matrix into the identity matrix, so we can easily able to find the inverse of the corresponding given matrix. So let us see the problem. Find the inverse of A. This is a 3 by 3 matrix by Gauss-Jordan method. Okay, applying Gauss-Jordan method, we have to write the particular given matrix A bar identity matrix. Okay, in this format, there is given matrix 2 1 1 3 2 1 2 1 2 slash this identity matrix 1 0 0 0 1 0 0 0 1. Okay, our aim is to change this into identity matrix by using the elementary operations, and the corresponding this matrix is called the inverse of the matrix. So we have to make this as 1 0 0 0 1 0 0 0 1. Okay, simultaneously here some numbers will come, so that is called the inverse of the matrix. So first we have to change this element to be 1. Okay, this is R1, so here 2 is there, so if we divide by 2 means this becomes 1, so R1 equals to R1 divided by 2. Okay, so 2 by 2 1, so 1 by 2 1 by 2, here also 1 by 2 0 0. Okay, rest row like as it is. So actually what we are going to do is we have to change this to identity matrix, and this is called inverse of the matrix after change this matrix. Okay, so first step is we have to change this 0, and next step is we have to make this to be 0, this 2 element to be 0. So obviously we have to multiply, here 3 is there, we have to multiply R1 by 3, so 3 minus 3 is 0, and like here 2 is there, so multiply 2 into R1, so it becomes 0, so 3 minus 3 0, so 2 minus 3 by 2 1 by 2, so 1 minus 3 by 2, 1 minus 3 by 2 means minus 1 by 2, like that. R3 2 minus 2 0, 1 minus 2 by 2 1 0, so 2 minus 2 by 2 1. Here also the same operations, R2 minus 3 R1, so 0 minus 3 by 2 minus 3 by 2, 1 minus 0 0 0 minus 0 0, here 0 minus 2 by 2 1, so minus 1, 0 minus 0 0 1 minus 0 0. You get the matrix like this, 1 0 0, so 1 by 2 1 by 2 0, 1 by 2 minus 1 by 2 1, so 1 by 2 minus 3 by 2 minus 1 0 1 0 0 0 1. Okay, so now we have to make this as 1, so here 1 by 2 is there, so we multiply by 2 means it becomes 1, so multiply the whole term R row 2 by 2, so write R1 as it is, and R2 0 into 2 0, so 1 by 2 into 2, so 1, minus 1 by 2 into 2, so minus 1, minus 3 by 2 into 2, minus 3, 1 into 2 2, 0 into 2 0, So R3 as it is. And now we have to make this term as 0. Okay, actually we just go by step. That is, we have to make this as identity element. Our aim is that we have to make this as identity element. Okay, 1 1 1 0 0 0. So this becomes to be 0. So next step is we have to make this as to be 0. Okay, here 1 by 2 is there. Okay, so using this operation, R1 equals to R1 minus 1 by 2 R2, that is multiply R2 by 1 by 2 and subtract from R1. We get this to be 0. So write R1 equals to R1 minus 1 by 2 R2. So R1 1 minus, so 0 1. So 1 by 2 minus 1 into 1 by 2 1 by 2 0. So 1 by 2 plus minus already there, minus is there, minus minus plus. So 1 by 2 into 1 by 2 1 by 2 plus 1 by 2 1. Okay, so here 1 by 2 plus 3 by 2, so 4 by 2, which is equal to 2, and here 0 minus 2 by 2 minus 1. Here 0 minus 0 0. R1 as 1 0 1, 2 minus 1 0. So R2 and R3 as it is. Okay, now we have to, here for identity 1 0, here 0 has to come, here 0 has to come. So we have to make this two element to be 0. Okay, using these operations. Okay, so that is using R3 make this 0, that is 1 minus 1 0, and using R3 this is 0. So plus, this plus means minus 1 plus 1 means 0. So using these operations, R1 equals to R1 minus R3, R2 equals to R2 plus R3. You have to make this 0 now. So R1 minus R3, so 1 minus 0 1, 0 minus 0 0, 1 minus 1 0, 2 minus of minus 1, so 2 plus 1 3, minus 1 minus 0 minus 1, 0 minus 1 minus 1. Okay, now R2 0 plus 0 0, 1 plus 0 0 1, minus 1 plus 1 0, minus 3 plus minus 1, so minus 4, 2 plus 0 0, 0 plus 1 1. So write R3. So this is the identity matrix. So we just may change this that is given matrix to the identity matrix. So the corresponding this matrix should be inverse of the matrix. So write A inverse equals to 3 minus 1 minus 1 minus 4 2 1 minus 1 0 1. So this is the method, that is Gauss-Jordan method, to find the inverse of the given matrix.